This is for Biology 223 Genetics. This is a problem of semester 2020, homework 3. Now we'll be doing part E. Previously we did, what was it? Part D. I was going to continue on in the same piece of paper, but unfortunately I forgot to push the record button properly. So let's continue on. We've determined already for, we've taken a little bit of a shortcut for D by determining the genotypes likely for 4-2, and then just directly with 4-1 determining what the genotypes of 5-2 would be without all of them. And that's fine. If you want to do a checksum to make sure all the gametes add up to 1, you have to do them all, and we have to do them all anyway now. So the question is, individual 6-1 being heterozygous at loci A and B. So being heterozygous can be either in cis or trans, right? Either of those. So we want both of those, and we want to add them. And notice that because the male parent here, excuse me, cannot contribute either the AB or the plus B, the male parent must be the source of the plus plus and the A plus. So we need to know the likelihood of individual 5-2. So 5-2, I'm going to write that 5-2 must produce, then we're interested in the AB, and also 5-2 here must produce the plus B. So we already know the contribution of plus plus and A plus from 5-1. That's easy, it's 1/2, 1/2. So the tricky part is knowing what gametes she can produce, and we can't figure out what gametes she can produce, and she undergoes recombination, being female Drosophila. We can't know that until we know her genotypes. So we know the genotypes of the father here. So we're going to first calculate what kind of gametes it is. So I just redrew it here, and let's write out the possible gametes he can make. A plus B. Properly I should be underlining the gametes because the underline shows it's linkage, it's not about ploidy. So how do we do that? The contribution of that is going to be the likelihood of being this genotype times the frequency if this genotype of producing that gamete. No crossing over in the male. The first time I did this, I forgot that. It was Drosophila, and did crossing over, and the problem got a little bit out of hand. And the question D was unlike question E, and question E was unpleasant. So let's go on here. So that's going to be 9/20 times 1/2. So 9/20, so A plus can come from here, 9/20 some half, or it can come, that's the only place it can come from. Plus B can come from this one, so 9/20 times 1/2, and nowhere else. AB can come only from this one, 1/20 times 1/2. Plus can come from all of them. There's two ways to do it. Okay, 9/20 times 1/2, 9/20 times 1/2, 1/20 times 1/2, 1/20 times 1, or I'm going to do a slightly different method, which is 1 times 1/2 plus 1/20 times 1/2. Okay, the methods are the same, come up with the same result, just to show you differences. Okay, so let's keep this in some common denominator, so it's going to be 40th. So we're going to have 9/40, 9/40. Here we're also still in 40th, 1/40, and here now, so we want 40th, so that's going to be 1/2 is going to be 20/40 plus 1/40, so that's going to be 21/40. So we have 21/40, 1/40, and let's write that A plus B, AB plus plus. So those are the gametes of he can produce of 4, 2, of 4, 2. So now we have to determine the genotypes of this individual 5, 2. So let's draw that here. So I'm gonna go back and repeat myself here, aren't I? Redraw this. So we're gonna have 9/40th chance of A plus, and we're going to have from, so A plus, plus B, AB, and plus plus from the, from him, right? And from her, we have, oops, I did something wrong here. This was not equal. This was 1, I didn't notate it, 1/4 and 3/4 here, right? That's 1/4, 3/4, because this parent was plus plus and this parent was A plus, plus plus. So many places make a mistake. So let's do a 3/4 chance here from her of being plus plus, and 1/4 chance of A plus, and 9/40th, 9/40th, 1/40th, and 21/40th. Okay, so these are coming from him, and these are coming from her, no recombination. So we have gametes of these two. We're determining possible genotypes of her in order to know what gamete production, whether she can, what proportion she makes these two gametes we need from her. So we're going to have, I'm going to keep it A plus over plus plus, and A plus over A plus, plus B over plus plus, plus B over A plus, AB over plus plus, AB over A plus, plus plus over plus plus, plus plus over A plus. Okay, fine, and we can calculate those. Now, what we need to know, individual 5, 2, right? That's her. So this is 5, 2. We need to know what gametes she can produce, and 5, 2 gametes we calculate from here. Possible are A plus, plus B, or plus plus, or AB. But we only need to know the plus B and the AB. We don't need to calculate all the other ones. I did calculate all the other ones, and the numbers added up all to 1, so I can tell you what I'm going to show you. It doesn't have a mistake, but there's no need to do it here. We may have to do 2 parts in this video anyway. So we need to know the likelihood of this gamete and this gamete from V2. So the contribution is going to be what genotypes contribute to plus B. Remember, she can undergo recombination. So no plus B from here or here, plus B here. So the likelihood of getting a plus B from this one is going to be 9/40, right? 9/40 times 3/4 times, if this genotype, no recombination, there's only one heterozygous locus, so times 1/2. A separate term is going to be from here, so it's the same as this, 9/40 times, this time 1/4. And now recombination is possible, and we want the parental, so that would be the 9/20, not 1/2, but 9/20. Okay, also we can get plus B out of this genotype with recombination, so that's going to be plus 1/40 times 3/4 times, this time the recombinant, which is rare, and is going to be 1/20. This one cannot make plus B, neither of these two, so that's that. And let's, I'm going to do this in 2 parts so I don't run out of time and waste everything. Let's add this up. I'm going to switch to red pen to do this. So which denominator should we use? 44, 2, 44, 20, 44, 20. Let's use 44, 20. So that's 160, that's 300, 3,200. So we're going to do this in 3,200ths. And we have here, well, let's just make this 10/20th instead. So 9 times 3, 27 times 10, that's 270, plus 9 times 9, that's 81, plus 3. So if we add these together, 270, that's 351 plus 3, so 354 over 3200 chance of this gamete plus B from who's this one? From V2. So the likelihood of being plus B A plus, so I'm going to do it here. So A plus over plus B is going to be equal to the probability of getting A plus from the mother, which is 1/2, times the probability of plus B from the father, which we just determined, 354 over 3200. So I could divide this by 2 or multiply this by 2, divide this by 2. I'm going to take the easy way, and I'm going to say that's 354 because we're going to add them together later. 6400. So that's from that. That's the calculation. That's half of it. So let's then do in the next video the other one, the cis rather than the trans. So this is the possibility of the trans orientation. We're going to do the cis orientation next.